Hi, I'm Patrick O'Hare, President of the Friends of Ludington State Park. The Friends is a 501c3 nonprofit organization that was founded in 1992. The mission of the organization is to provide and support programming and projects at the Ludington State Park. Thank you for taking the time to watch our Zoom recording of Alan Wernette's Great Lakes, Past, Present, and Future. We hope you will take the time to explore the Friends website and consider becoming a member if you are not one already. You can also find information on the website regarding past, current, and planned projects, future events, volunteer and donation opportunities, prior news, or to register to receive our e-newsletters. On behalf of the Friends Group, we hope you enjoy Alan's presentation, and now I will turn it over to him.
Hey, I want to say thank you to Patrick and to all the Friends Group and the volunteers, because they do a wonderful job, and they have for all the years I've been here. Boy, they've done so much for us, and they continue to. So without the Friends Group, we'd still have a park here, but we wouldn't have all the amenities, the beautiful, nice amenities that we take for granted that are here now because of the Friends Group. So yeah, I really appreciate that. So, well, I've been asked to do the Great Lakes of North America, and I did the same program last year, but I've changed it a little bit, just so if you saw it last year, there's a little bit changes here and there, and that's okay, because there's so much to learn and know about the Great Lakes that I could have a whole new presentation every time. But I'll talk a little bit about some things will be the same, but some things will be different. So that's what I've been asked to talk to you about. Again, my name's Alan Wernette. I'm the park interpreter. That means I do educational program. I don't interpret languages. So if someone comes here and speaks Japanese, I can't interpret it. I have no idea what they're saying, but I can interpret the nature in the park to people that maybe don't understand the sand dunes or don't understand the Great Lakes like I'm talking about tonight quite as much. You know, they enjoy it. They love seeing here. They love coming here, but maybe they just don't quite understand it. So that's my job as an educator at Ludington State Park. And of course, you folks took in, probably some of you took in the presentation by Peter Manning on the Big Sable Point Lighthouse. It's obviously a big draw to also to the state park, and we're very proud that we have a good volunteer group out there that takes care of it and keeps that up also. So we're lucky. We actually have two great groups that really care about the park and help out and take care of it for us, help us take care of it. So the Great Lakes gives us a lot of great, beautiful places to visit, to enjoy. And this is one, Pictured Rock State Park up on Lake Superior. And we could spend all night looking at just nothing but pictures of the beautiful areas along the Great Lakes. But let's jump into a little bit about the Great Lakes. We're going to talk about not only the present, but we're going to talk about the past. In fact, I want to kind of emphasize a little more of the past tonight, what was here before the Great Lakes. And then we'll talk a little bit about the present, and then a little bit about the future too. But before we do that, again, the Great Lakes are sometimes called the inland seas of North America. And what makes them unique? They're fresh water, okay, no salt water. And there's also no sharks or jellyfish, things like that you'd find in the ocean. And I always like to pick up my great big globe here that I show the kids when I do my virtual school program for the kids. And I show them, this is the vast world that we live on, this big world we live on. And what's interesting, when you go over here to North America and you look at, this is only a small little area on our surface of our earth is the Great Lakes. Okay, it's not a very big area considering the size of our earth, but it's unique because it contains 1/5 of all the fresh water found on the earth. Okay, that's 1/5 of the whole fresh water on the earth, and that's unique in itself. So that's really cool. Now the Great Lakes there's 5 Great Lakes, and they all have names. And it's easy to remember the names of the Great Lakes if you can just remember the word homes, Homes, every letter of that word home stands for a Great Lake: Huron, Ontario, Michigan, Erie, and Superior. When it comes to the different Great Lakes, I play a little game sometimes, trivia with people and visitors that come to the park, and I'll ask them, what's the biggest Great Lake? Well, that's a trick question. In fact, that was a question that was on a game show about 20 years ago, maybe 15 years ago. What's the biggest of the Great Lakes? Well, everyone thinks, oh, Lake Superior. Okay. Yes, you're right. Lake Superior has more water in it than any other Great Lakes. Okay. It's vastly bigger when it comes to volume water. But when it comes to surface, if we just look at the surface, don't look at all the other water, just the surface, actually, Lake Huron has more surface water. Okay. Lake Huron is. That's a little question. And that was a game show question. And the person got it wrong and he appealed it. And it was in the newspaper, I remember. And they gave that person the chance to come back because that person was able to prove that Lake Superior is not, it all depends what you're talking about on the Great Lakes. So the Great Lakes are all unique, very special, all together, unique area. So now let's talk about the past. I like to talk about what was here before the Great Lakes, because that does have a factor on what we find today around us, okay? What was here in the past. And so this is a pictorial look at the Earth, somewhere several hundred millions of years ago, almost a billion years ago. And if you notice, I drew a red line on that to show where the equator was at that time. You'll notice that the equator goes through what now shows up as the Great Lakes, okay? Michigan there. And that's why Michigan has an abundance of coral fossils, which we're going to talk about, because this area of the world at one time was at the equator, okay? Was at the equator. And again, evidence shows us that we were at the equator at one time. Of course, the Pangea broke up and the North America continent actually moved north by northwest, okay? And so now we're not at all close to that, but at one time we were. And so there was a very vast shallow ocean here at one time with teeming with sharks and coral reefs. And this, again, it was a saltwater ocean. And there was, prior to that, there was even volcanoes here. And I'm going to talk a little bit about that too, as evidence here. And this slide shows it. Now, I learned this because my son is a geologist, and he taught me this, and I didn't know that. I didn't know this. The western half of Lake Superior and the western half of the Upper Peninsula are actually, at one time, they were very geological active areas. Why we know that? Well, we have iron ore that we mine up there. They have copper up there. All the things that we have, the Huron Mountains, we have the Keweenaw Peninsula, the Porcupine Mountains, all the things left behind by a geologically active volcanic rifting area. Okay. And this is actually the lighty shaded area that shows it. Actually shows, maybe you can see my mouse here? This area here was a geologically active area somewhere about 2.5 billion years ago. Actually, it's part of what they call the Canadian Shield. The Canadian Shield, some of the oldest rock on the surface of the Earth is the Canadian Shield, and the western part of the Upper Peninsula is part of that. Okay, volcanic activity, rifting, where the ground would actually sink down, open up, lava would come up through the rifting valleys, sink down the weight, and this happened over a long period of time. So the western half of Lake Superior was a very active area. That stretched all the way down into Kansas, the state of Kansas. That rifting area stretched all the way down there. Now, it's no longer, but we have evidence on the ground. We have evidence that shows us a volcanic activity. We have granite, and I have one here I'm holding up to the thing, a piece of granite, beautiful piece of granite, very hard rock. You cut it and you polish it. You can use it for countertops and for fireplaces, just a gorgeous rock. But granite is an igneous a rock, type of rock. It came, and you go to the UP or West Park, you'll find granite everywhere. Hills, mountains, old mountains of granite. It's very, very abundant, along with some other, the basalts. The basalts were also very abundant. on the ground or found there up there. So that's evidence that at one time there was a volcanic activity in that area. Now let's move a little bit more away from the way back, the billions, and let's go into the hundreds of millions of years. There was an ocean here, okay, and this is out of the Doran Eschman Geology of Michigan book. This actual photo here. This shows approximately what it looked like, what was happening about 500 million years ago in this area. There was actually a basin of there was a Michigan basin that was a shallow, warm saltwater ocean surrounded by coral reefs. Okay. And then below that, there were other little basins too. Now, how do we know that? Well, all we have to do is look on the ground. And what do we find on our ground? We find, let me turn this around, we find fossils. This happens to be chain coral fossil piece that I just found. And of course, this is the most obvious type of fossil that most people are looking for in our state. And this is the Petoskey stone. These are types of coral that have fossilized over millions of years. And we can find coral anywhere in our state. The other type of rock we can find in our state, and it's the most abundant rock in our state, is limestone. Limestone. Limestone is found around Chicago. They quarry it down there. I-80 actually goes through a limestone quarry. Detroit area has limestone quarry. Even mid-Michigan, lower part of mid-Michigan has limestone quarries. Limestone is super abundant. It comes from shallow, warm oceans that existed at one time. What happened? Basically, you see those arrows that show the water inlet and the water outlet. Excuse me. Over millions of years, those outlets and inlets got smaller and smaller and smaller. So basically, they no longer allowed the water to come in and go out. And when that happened, the inland ocean got trapped. That shallow inland ocean got trapped in the Michigan basin, which then trapped it. And over time, the water evaporated. And if you're from certain parts of the state, like Detroit area, Metro Detroit area, down in that area, you know, there's salt mines down there, vast salt mines. But a lot of people don't realize, even in Ludington here, okay, OxyChem, they have wells and they inject hot water deep into that salt layer down there, and it melts it dissolves it, and then they pump it out. And of course, we utilize the salt down in the Metro Detroit area, Windsor, Canada. They mine the salt, and we also get it here. So there's this vast salt layer left behind by that ocean that evaporated away. A lot of kids will ask me when I do this program for kids, how come the Great Lakes water doesn't dissolve the salt down there and make the Great Lakes salty? The answer is, for when the ocean finally evaporated away and left a layer of salt, also there was other sediments building up on top, other sediments piling up on top of that salt. And those sediments eventually hardened, became a rock, impermeable rock, and that keeps the fresh water from reaching down into the salt water and making the Great Lakes salty. There's that thick layer of rock. It's I tell kids it's like putting a lid. You put some food in a Tupperware thing and you put a lid on it, okay? Then let's say you put something else on top of that. Well, that lid's stopping that whatever you put on top from reaching down underneath that lid. That's kind of, in a way, in a nutshell, what happened. Okay. And so we have evidence that this existed at one time. We changed a lot, and I like to throw this slide in there for the kids to show the hammerhead shark and show beautiful coral reefs. All of that existed at one time here, long before the Great Lakes were here. So, and here again, Petoskey stone, horned coral fossil, things that you could find all over the state. So now we're going to move into a time after the ocean had evaporated away, the basin is gone, the water in the basin's gone. And basically what we have for a few million years is we have an area with still sediments falling, depositing on top, but there's no ocean here anymore. But now we have the softer rock. The softer rock gets dissolved by water. When it rains, it melts and it dissolves that rock and we get river valleys. And this is what we see is a river valley system, not the Great Lakes yet. It's a river valley system. Now you notice looking on this graphic, you can see that they've imprinted the Great Lakes over, over top of that river valley. You can see those river valleys pretty much follow the same course as our Great Lakes do. And in fact, under the Mackinac Bridge, from under the Mackinac Bridge in the middle, over to Mackinac Island, between Mackinac Island and St. Ignace, the glacier actually didn't completely destroy. There's still evidence of an old river valley that flowed through there. Okay, it's still there. That channel, that little piece of river valley is still there up in that area. And that's pretty cool that that river valley still is evident. Most of the place, the river valley is not there anymore. So the question is, what brought the ice age on? And there's been a lot of theories. And about a month ago, I happened to be watching, I like to watch like the Smithsonian Channel a lot and the National Geographic Channel a lot. And I can't remember which channel it was, so I apologize for that. But there was a special on the dinosaurs, the extinction of the dinosaurs. And I watched that very, very closely. And I think they were saying that almost all the researchers around the world believe that the reason the dinosaurs went extinct so fast, I mean, it was a massive extinction real fast. The only thing possible that could do that would be an asteroid, a meteor hitting the Earth. And it had to be a substantial, good sized meteor. Now, this picture you see is the one near Winslow, Arizona. And it's big, but the one that actually hit the Earth during the time of the dinosaur demise was actually much, much bigger than this. As a matter of fact, the Yucatan Peninsula down in that area near Belize and all that, that is a massive volcano. And they actually show the graphics. They've done ocean bottom thing. There's actually one huge rim that's over 100 miles. And it had to be a huge asteroid to hit the Earth. At that time, what would happen? You would have an instant evaporation of the water would evaporate instantly from the impact. Also, you had this huge cloud being pushed way up into the atmosphere, gigantic cloud that would then encompass the whole Earth. And that cloud encompassing the whole Earth would shade the ground, so the sun could not reach the ground. Thus, the Earth started to cool extremely fast. And when the Earth cools fast, plants die. And also, guess what? The dinosaurs no longer have food. And so there's this mass extinction really, really quick. Okay. Now, it's widely believed that was the beginning of the Ice Age, too. And it seemed to have the study between the two seemed to go very, very close to each other. The Ice Age and the extinction of the dinosaurs. And that would make perfect sense. The Earth cooled down extremely fast. Now you had perpetual winter in certain places of the globe of the Earth, the northern hemisphere, the extreme northern hemisphere. You had this perpetual winter year round for hundreds of thousands of years that would create snow until you build up and you get a massive glacier, moving glacier, continental glacier. And so we have the Ice Age. The Ice Age is now started, okay? And let's see, right here is where they figure down here, if you can see my little cursor, right around here is where they figure they know there's actually remnants of a humongous crater from the hitting. And so we get this ice buildup, snow, ice buildup year round, no summer, no warm summers. And this over time, this ice gets so thick, we're talking about 7 miles, in some places even more. And it gets so thick that the weight of the ice is pushing down, causing the bottom of the glacial ice to actually get squeezed out and move. And as it does, it digs, because you got miles of ice on top, and it's pushing down as it's moving, and it's digging and digging. And voila, you start to get the formation, different shape of the land formations, such as the Great Lakes. The other little graph there shows approximately how much of North America, or how much of the United States, I should say, the lower 48 United States, how much of it was covered by ice. And as you can see, most of the United States was not covered by ice, okay, by the glacial ice. It was affected still by that time period, the ice age, the cooler temperatures, but not enough to keep the snow and stuff on the ground. So this would be the extent of the last glacier, the Wisconsin glacier, as a Wisconsin glacier that came through. And you can see it actually, they imprinted again where the states, all the states are. You can see our state, Michigan, and our Great Lakes are all underneath that moving massive miles of ice. And here's a good graphic that shows, I like to tell the kids, the earth started to warm up, okay? That debris cloud over thousands of years, that debris cloud finally got thinner and thinner. Those particles came down to the earth. Now the sun could reach the ground more. The sun started to warm up the earth's surface. And as it did, the glacier started to melt back. But that doesn't mean they just kept melting away, okay? The glaciers, there were time periods where all of a sudden the glacier would start moving forward again, okay? Then it would melt back a little bit and then it would move forward again. And that happened over and over and over, okay? And that's really when the Great Lakes were really being formed, because these finger-like extensions off the main part of the glacier, these finger-like extensions here would actually move through these low river valley areas, and they would dig deep. These lobes, the Lake Michigan lobe, the Huron lobe, they'd move deep into these river valleys and dig down, and then they'd melt back again, and then they would start moving forward through that valley again, just digging every time. It's like a bulldozer pushing, backing up, pushing some more, backing up, and it's making the hole bigger every time it does it. That's a classic way that the glacier was carving the Great Lakes out, till finally the earth warmed up enough where the massive ice sheet did melt back far enough and those lobes did come back through. And as you see there, we have the Great Lakes, the formation of the Great Lakes. And as I tell the kids, we have our mitten, the lower peninsula mitten shape. And not to exclude anybody inland, we had glacial hills, glacial lakes, inland lakes, kettle lakes, eskers, drumlins. We had the shaping of the inland too, the land on the inland side too, not just the Great Lakes itself. So all of Michigan was shaped by the Great Lakes. All of it was shaped like the Great Lakes. Okay, so that is a big factor to realize. Now we're moving into today. Today is the watershed of the Great Lakes today. Basically, watersheds are when a raindrop falls on the ground or snow melts, it's going to move downhill in streams and rivers and out to lower levels, in this case, the Great Lakes. So any water drop, snow melt in that area is going to move towards a Great Lake. And that's the watersheds of the Great Lakes. Very, very important. I try to emphasize that with students, okay? Especially young students. As you get older, you're going to hear more and learn more about watersheds, because if you pollute a watershed, you're not just polluting something in your neighborhood or around your house, you're also causing a factor downstream in the watershed. And one of the most important, I think, one of the most unique, not important, one of the most unique features of our Great Lakes is Niagara Falls. You live in the Great Lakes region, the watershed of the Great Lakes, if you have a direct connection to Niagara Falls. I tell kids this all the time. When I go to Niagara Falls, it's one of my favorite places to go. And I just stand there at the railing and I don't say anything to anybody. I just stand there and watch all that water fall over that cliff. And I'm thinking, I have a direct connection because I live in the watershed. Now, maybe a couple drops of water going over that had directly hit me, or maybe where I live. There's a direct connection. And I think that's so unique when you think of millions of people every year from around the world visit Niagara Falls because they're so beautiful. But we have that direct connection, which even makes it even more special to see. And so the other factor is what keeps the Great Lakes water? What keeps water in the Great Lakes? Well, obviously, what's going to keep water in the Great Lakes is rain, the amount of rain we get, and the amount of snow. And the snow will melt, of course. Hopefully it melts here in a couple months. Not right now, because I still got another snowshoe Saturday to come. After that, it's okay. But the watershed of the Great Lakes depends on the amount of rain and snow. And here you can see the graph. This is from the Army Corps of Engineer, the Great Lakes District. And they actually, since almost well over 100 years, since 1918, they've been watching the water levels of all the Great Lakes they actually watch it day by day, by the week, by the month, by the year. And what they see is this heartbeat like thing, graph that goes up and down. Okay. The Great Lakes don't always stay at the same level. They do change quite a bit. Okay. Some change more than others. Okay. Look at Lake Michigan. Lake Michigan and Lake Huron are geologically the same lake. The only thing that makes Lake Michigan different from Lake Huron is humans. Okay. We like to take the Mackinac Bridge or the Straits of Mackinac and make an imaginary line, and one side's Lake Michigan and one side's Lake Huron. In reality, they're the exact same lake. Okay. So whatever the level of Lake Michigan is the same level of Lake Huron and vice versa. Okay. That's why on this graph, it shows them together, because they really are geologically the same lake. So you can see over the years, the lake level goes up, maybe because we have more rain, maybe more snow. The lake levels go down. No, maybe we didn't get as much rain those years. And so it goes up and down. And just a couple of years ago, we had really high level water levels because we had a lot of rain throughout the year. We had other things that would cause the water level to go up in the Great Lakes. Now, since about a year ago, the water level has actually gone down almost 2 feet, almost 2 feet. But that doesn't mean it's going to continue to go down. It could go right back up again, because look at the little graph. It's like someone's heartbeat. It goes up and down, sometimes go way up, sometimes go way down. All right. So it's pretty interesting. You can look online, and this is all free information. You can get it and watch it. It's pretty cool to watch the different lake levels. We've talked about some of what would cause the water levels to go up and down. And we mentioned rain, we mentioned snow. The third thing we didn't mention that's very, very important, especially this year, is evaporation. Okay. And it's something I like to kind of tease our summer visitors down at the Lake Michigan Beach House. We have 1,000 people on a hot summer day, sunny day at the Lake Michigan Beach House. I can set up a little stand there, and I could show them this thing. And what I usually show them is a glass of water. I'll show you here. I'll show them this. I don't have it full of water, but I'll fill water up to this water level, and I'll say, imagine this is all the water in Lake Michigan up to that water level. Then I ask them a real simple question. Everybody a question. When is evaporation going to happen the most in the Great Lakes, like Lake Michigan? When does it happen most? Is it on this day where it's 95 degrees and it's sunny, not a cloud in the sky, and it's hot, and you people are just sweating like crazy? It's so humid. The humidity is really high. Wow, is it today? Or, before you answer that question, or might it be in a few months from now when it's freezing cold, super cold? Maybe, when do you think it's going to happen? Well, I'll ask, okay, how many think it's in summer? How many think it's in the winter? Almost all the people, adults, raise their hand. Oh, it's happening in the summer. It's happening in the summer. Yeah, definitely. Well, then I show them this little trick, okay? Or not a little trick. It's a little prop that I use. I'm going to set this down so I don't get water on my computer. Last thing I want is me to all of a sudden the computer go dark on me. I use 2 sponges. One sponge is a pink sponge, and I label this pink sponge a warm, moist air, because this is the kind of air on that hot, humid day. This is why you're sweating. Your body's having a hard time to cool down, because the air is so humid. There's so much water in the air. So if I take a warm, humid air sponge and I try to put it in water, how much water is going to absorb in this sponge that's already so full of water that it's dripping out? Not much. But on the other hand, if I take a cold, dry winter air mass, which is going through the last few weeks, now not tomorrow, but we've had just previously for several weeks, cold, dry air masses going over us, and it's been really cold, like six degrees above zero the other day, wind chill below zero, very dry, cold air. Okay. And this sponge represents that, and it's dry. And if I stick this dry sponge in that water, what's going to happen? It's going to soak up a lot of water, isn't it? And when it soaks up a lot of water, guess what happens to my water level? It goes down. In fact, I got some cool videos this year, and I meant to try to get them on today, but I just didn't have time to get them on here. Videos of, you can actually see the water, a video of the water of Lake Michigan actually looks like the lake is bubbling away. The water is going up. You can see it evaporating, and then there's clouds up high there. Okay, that's classic evaporation. When does it happen more? In the winter, not the summer. Okay, so evaporation is very important for the water levels, all right, of the Great Lakes. This slide shows the river, the Big Sable River, flowing through the state park on a cold, dry winter air mass going over, and you can actually see it evaporating. The next slide here shows a photograph from the International Space Station looking down on this daytime on the Great Lakes on when a cold, dry air mass. This could have been, this was taken a long time, a few years ago, but this could have been just 2 days ago, this picture, okay? It could have easily been taken 2 days ago when that cold, dry air mass from the Arctic in Canada came down over us and blew over us, giving us our lake effect, our classic lake effect. So what happens? I like to explain to people, we have this beautiful beach here at Ludington State Park, natural beach. But some years that beach is small and some years it's very wide. This picture here is from 2013. It's a very wide beach because at that time we had low water levels. The water levels in the Great Lakes and Lake Michigan and Lake Huron especially were low. Okay, how low? Well, about 3 feet lower than they are right now. If I went out to the lake now and measured the lake now, and then I measured 3 feet down, the entire lake surface had 3 feet less of water than it does today. That's from Chicago all the way to the Straits, all the way to Port Huron, down on the southern end of Lake Huron. So three extra feet less water. Okay, that meant our beach was huge. We got this gigantic beach, and it was great because people could really spread out and do a lot of different activities because they weren't on top of each other at that time. And the reason we had that is because a few years before we had low rainfall, less rain than we normally would have had in the Great Lakes. And we also had very cold winters. And with that cold winters, we got a lot of evaporation. And so a lot of water out of the lakes was taken up. So the lake level went down. Okay. Simple math, real simple math. This happens over and over and over. Well, then guess what? Nature doesn't always stay. Remember that graph I showed you? It goes up and down, sometimes way up. Well, guess what? We started getting more rain in the Great Lakes region than normal, a little more rainfall than normal in a whole year. And we got a little more snow than normal. And we had warm winters. And how do I know we have warm winters? I'm the guy that does the snowshoe programs. I've been here 20 something years doing snowshoe programs. And I can tell you of several of those years, I was lucky to get a couple snowshoe walks in if we had snow. Okay. And so we had warm winters. In fact, last year was the worst, one of the worst years, because there was only once I got to go snowshoeing on one weekend only last year. That's all the snow we got here. And there was no ice on Lake Michigan last year to speak of here at Ludington State Park. And so we had low evaporation. Okay. We didn't get the evaporation. So without the evaporation and with higher rainfall, guess what? The water levels of the lake, okay, waters of the lake went up. And when they went up, guess what? Our beach here at Ludington got smaller. Now, we were lucky. We didn't lose all of our beach here, okay? But some parks did. Orchard Beach State Park up in Manistee, this is what their beach looked like, okay? What beach, huh? The water was banging up against the bank there, that bank ridge to keep it from washing away. But there's no beach right now, okay? The beach was gone. They didn't have a beach. In fact, this metal stairway, the park staff up there had to quickly unbolt it and pull it all the way up and close that stairway off, because that stairway would have been taken out by the waves and storms. So what caused all that again? We had above average rainfall and not very much evaporation over the winter. So the water levels went up. Now, the next picture is of Jim, the manager here, Jim, and some other people walking just north of the lighthouse. And this is one of the dunes that is getting washed away during the high water level of 2000, okay? 2020, I should say, 2020. And storms would come up and it'd wash this sand dune more and more away. Nothing to panic, because there's no houses built on top of that, okay? There's no roads up there, nothing to panic, because when water levels go up, they will come down. And when water levels come back down, we get more beach, more shoreline. The sand dune here will start to work its way out and grow. The grasses will grow out, more sand collect, and that sand dune reforms, okay? So that sand dunes right next to the lake tend to get washed away, and then they'll come back for a few years. Then they get washed away and they come back. That's a normal thing to happen. So what happens when we do this? What happens when we forget about that? We forget about history, and we go and we build structures of all kinds, stairways, houses. We build things next to the shoreline. Guess what happens when the water comes up really high? It starts to take away those beautiful things that we spent money on to get down to the beach or get to the beach, okay? And in fact, this coming week, sometime this week, and I'm not sure what day it is, Interlochen Public Radio has an Up North. It's a regular weekly program called Up North, and this week's topic is the coastal changes. And they're going to talk about how the lake changes, like I just did. And they're going to talk about legislation, politics that are involved, all kinds of things you hear about on the news. The one thing they have little excerpts, and the one thing I did hear that is very, very true, whatever you do, and see what these people did on this one here, they put all these rocks along the shoreline. That's only temporary. Whatever you do, that big Great Lake is going to win in the end. It will end with that Great Lake winning. It will. The rocks along the shoreline are only a temporary purpose. They might give you a few years, but eventually the Great Lake is going to take what it wants to take when the water level's high. And that's a shame. That's really sad, because people build beautiful structures along the lake. Sometimes it's a house, and that house gets washed away, falls into the lake. Okay, something to keep a thought on. It's just part of the nature of the Great Lakes. It's part of the nature. It's not something evil out there trying to ruin your life. You know, it's part of the nature of the Great Lakes. We got to realize that. We got to understand it better. Okay, that's all I'm saying. We need to understand the power of the Great Lakes more than we do, because golly gee, I tell people on a nice, beautiful, sunny day in the summer, I say, wow, wouldn't it be nice to have a house here and a deck, and you sitting on your deck chair with a cup of coffee in the morning, looking out over the beautiful Great Lake here, Lake Michigan. And I said, yeah, that would be nice, but what happens when the water level comes up? Okay. And then I explained to them, I said, so, sometimes you can't have everything. All right. So I'm almost finished here. I'm starting to get to the end here. And I do need to real quickly talk about invasive species in the Great Lakes, because that's one of the things. I do a lot of invasive species program, and this is the one that I especially talk to a lot of school groups from across the state. And this is the sea lamprey. You can see me holding it up here, the sea lamprey. So we talk, I have a whole program I do virtual for school groups called this on the aquatic invasive species, how they get here through ballast water. Sometimes not everything got here through ballast water. Okay. Sometimes people purposely put things here like goldfish and carp. Carp and goldfish aren't supposed to be in the Great Lakes region, but they have been, because people put them here for decades and decades, and that's not good for our native fish anyway. But some things sneak in too, like the sea lamprey. The sea lamprey sneaks in with ships. As ships come from the ocean into the canals and locks to get around the falls, and they go up. These little critters swim in beside the ships, and they go up and they get into the Great Lakes too. So it's not just ballast water that we need to be concerned about. And here's some of the invasive species: zebra mussels, quagga mussels in the one corner. Those are people. This is hard for people to fathom. Is that zebra mussels and quagga mussels clean the water? Now you're thinking that's good. Well, it has been good in some places. Okay, like the River Rouge down in the Detroit area is much cleaner than it ever was, thanks to zebra mussels coming in. Parts of Lake Erie are the cleanest they've ever been because of zebra mussels. However, beware, zebra mussels clean the water too much. Okay, and when they clean the water too much, they make the water perfectly clear, and the sun can reach deeper down into the water. And if there's any kind of nutrients down there, like fertilizers that got washed off from someone's lawn, that sun and those fertilizer nutrients will become algae blooms. And then you got algae problems, okay? Or the other part of cleaning the water too much is there's no food left for the native species of aquatic things that live in the water, okay? There is a food pyramid. Little things eat the little food. They get eaten by bigger things, get eaten by bigger things. And if you take the bottom of the food chain out because you cleaned it up so much with zebra mussels, there's no food down there, then everything above it doesn't have any food. So those are some of the drawbacks to the zebra mussel and the quagga mussel, okay? And then there's other types of invasives here too, the gobies, which have really affected our rivers, inland lakes, some of the plants that have gotten into the Eurasian water milfoil, the spiny water fleet, little things that have gotten in. Again, here's some other things. There's the sea lamprey are here, and there's a whole program how I do that, talk about it. The Asian carp are in here. You see that one behind me, that Asian carp behind me, that is a 5 foot tall cutout of an actual what the actual size of a Asian carp is. And Asian carp eats a lot of little food. They don't eat other big fish. They don't eat other fish. They eat little tiny food, and they're just like a big vacuum cleaner, just gobble up the food. And then our native fish don't have enough food. Okay. And so why is all this important to us? I always like to get at the end of this slide here. All you have to do is look at the photograph. Okay. People love the beach, not just Ludington, but they love our Great Lakes beaches. Okay. Or they love like the Pictured Rocks area. That's beautiful up there too. Okay. People love to swim in the Great Lakes. They love to use the Great Lakes for swimming, sailing. And also look at the boat. The guy's fishing. Fishing is over a $9 billion a year industry in our state. People buy boats, equipment, they buy gas to get around. They go to hotels, they go to restaurants, they spend money. It's over $9 billion a year in the Great Lakes. So we want to protect all that. And so there are things you can do. One of the things that the Michigan DNR is really, really pushing, if you have a kayak or any kind of boat, we ask people to clean that boat before you take it to another river or lake, okay? Because you don't know what you're transporting, okay? In some parks, we don't have one here yet, but I think maybe in the future we will. They actually have cleaning stations at their boat launch for people to get those possible invasive species off that boat before you take it to another place and put it in. So I like to throw this slide in because that ship right there on a nice sunny day, it's the same ship on Lake Superior on a stormy day. And look how big the waves are on that. That's kind of an awesome, awesome picture. So I want to say thank you. And let's keep our Great Lakes special for all time and all generations. So I'm going to stop there. And if there's any questions.
You do have a question in the chat, Alan. It's from Walter. Looking at the water level of Lake Michigan over more than 150 years, it appears the high to low level has a fairly regular period of 15 to 30 years. Do you know what drives the longer term periodic level changes of almost 6 feet?
Yeah, there's a lot of research going on this right now. of the periodic changes in the water going up and down. And what they've noticed, and if I guess if you went into the Army Corps and you studied it closely, you can see that that period is getting a little bit closer and a little bit closer. Now we went from 2013 and 14 at an all-time low water level. We went from that 2013-14 to 2019 and 20 at a high water level. We just missed breaking the high water level on Lake Michigan in 2019. So that's only a period. That's only a period that they've never seen before, that drastic period. In basically 5 years or less, we've gone from a super low to a super high, 5 extra, almost 6 extra feet of water in such a short period. And there's a lot of discussion, just like you see fires in California, instead of a fire season now, they're saying fire years. A lot of things on Earth. And I think this is one of maybe the things also that's affecting the Great Lakes, where we're seeing the Great Lakes water level really be affected on not a longer period of time, but a shorter period of time. It's still being studied, I have to admit, because we're talking about years here. It's not something we can study in a lab over 3 weeks. It's something that you have to look at over years.
One of the things that I always find interesting is the fact that the Corps of Engineers, if I'm remembering my numbers correctly, one of 6 monitoring stations for lake levels on the Lake Michigan, Lake Huron Basin is here in Ludington. And so they use that as one of the 6 that they record, and then they go through some averaging of those 6 or however they do it. But I always just find it interesting. And you can actually go out and find that weather station, I should say weather station, the monitoring station, which includes a weather, you know, in terms of temperature and so forth, and look at the data. They push all of that data as well. And so it's interesting because it's actually inside. You probably know where it is. It's inside on the Pere Marquette Lake, and I always find it interesting to see the difference in what's recorded there versus what they record as the official level for Lake Michigan.
Because wind might have a factor. If there's a strong westerly wind, you know, the monitor station here is going to probably show a little higher water level. But on the eastern side or the western side of the lake itself, over by Wisconsin, that's showing a little lower. So they got to average those out. You're absolutely right. You're right.
The other, do you remember, as you were talking about evaporation, when I've heard the folks from MSU, from Sea Grant present and so forth, you know, people always, your Niagara Falls photo showing the billions of gallons of water going over. But the outflow is actually, the evaporation in terms of the impact on the Great Lakes level, if I'm not mistaken, is actually greater. I can't remember percentage wise.
I don't remember. I've heard that. I watched that presentation too. I've been to things where they presented, and it's I can't remember the exact numbers, but it's the evaporation rate is outstanding. You know, the amount of evaporation that comes out of the Great Lakes, is a lot more than what's going over Niagara Falls, and it's just unbelievable that evaporation. But you get a warmer winter, and you don't get that amount of evaporation. That water then's left behind in the lake, so that water level is going to go up too. So but you're right. Sea Grant does have a whole thing on that, right?
So there is a question in continuing that line in terms of, does the cover during the winter affect the amount of evaporation?
Sure does. Sure does. The sooner we get ice on the Great Lakes, and the amount of ice that forms on the Great Lakes, it's like putting a cover on something. If you have a pan of water just sitting there, and you just let it sit, it's going to slowly evaporate in your house. Okay, your air is going to evaporate out, and then the pan will go empty. But if you take that same pan of water and you put a lid on it, okay, that lid is going to hold it in. Think about it. You put something in I do this quite often. My wife gets mad at me. I'll put something in the refrigerator without putting a lid on it, and then a couple days later you take it out and it's all dry, and because it dried out in the refrigerator. If I would have put a lid on it, it would still be pretty good. It wouldn't be dried out like it is. So ice is a lid on top of the water. The problem we're having is if we have a warm winter, we don't get that ice. And number two, this year, for example, we didn't start getting ice cover until the third week in January. Typical winter, we'll get ice cover starting just about between Christmas and New Year's, somewhere in there, you start to get ice cover starting to form on the shoreline. But it didn't start here until the third week. And that's because all of the Great Lakes last year, the same people, the Army Corps of Engineers, they measure the temperature of the water of all the Great Lakes at different points. And all the Great Lakes set all-time high water temperatures. And just think that massive Great Lake has to cool down. That water doesn't cool down rapidly. It takes a long time. And this year it took to the third week in January for ice to start to form on the Great Lakes. So yeah, if you get ice cover that goes way out, yeah, that's going to stop the evaporation, the lake effect by far. Yes, definitely.
Alan, one of the things when you were talking about the invasive species, I always, in the last 2 years, maybe it was last summer, when we had that ship in that international from France or whatever, and it had to go back out and dump some of its ballast, but apparently had to go over towards the Wisconsin coast. Are you familiar with that in terms of the designated place in Lake Michigan? Do you know what I'm talking about?
Well, there is an international law that doesn't require, but it kind of mandates, but it's not super strong law, that basically asking ships before, while they're in the St. Lawrence Channel, before they come in, to empty their ballast water at that point, and then take on new ballast water at that point. Empty what they have and take on. But that means a ship has to stop, pump out its ballast water, pump in new ballast water. And as a business person, you know, that's money. When you're stopped in your tracks doing that, that's money. Every minute that goes by, every hour that goes by, that's money. So a lot of ships are international and they don't really follow it. And there's really the Canadian and the US Coast Guard really just don't have the time, the manpower to go out there and mandate, okay, did you empty your ballast? I want to see it, da, da, da. We just don't have that, the enforcement part of that to make it happen. And so ships still could come in, and we just hope, faith, that they've done what they should, or put a chemical. There is a chemical that they can add to their ballast water that will kill all organisms in there. But again, that's money. And if you're a business person halfway around the world and you don't have strong environmental conscience, then you don't give a darn, you're going to let it go. And so that's still a problem we have in the Great Lakes. It's still an ongoing thing. It's an issue, and it's become a very political issue, because how do you enforce international things in the Great Lakes? I mean, or do we fund the money? Do we going to fund it to enforce it? I don't know. Those are questions I can't answer.
If anyone has a question and wants to unmute themselves, they could ask it, or you can put it in the chat as well. This is not related so much to Great Lakes, but you commented in terms of snowshoeing and so forth. What's your prediction for this Saturday? The Friends group is always asking.
I know.
And Steve Banash is on, and of course he'll always say, please let us know as soon as possible. So what's your prediction on Tuesday from Saturday?
Well, tomorrow and Thursday don't sound the greatest. Friday might be a mix. I just don't know. I'm hoping tomorrow it's supposed to be rainy and 40 degrees down there. So we're going to lose a lot of snow tomorrow. It's obvious we're going to lose a lot of snow tomorrow. And we only have about 6 inches packed down snow right now. And what happens, I guess, late Thursday and the Friday is going to dictate it. So at this point, it doesn't look good. But I said that last week. At this time last week, I said it doesn't look good for the 12th. But then I heard that there's a possible chance of snow on Friday. And then we got, 4, 5, 6 inches of snow, lake effect. So it worked out great last Saturday. So I'm not going to go on a limb and say it's going to be bad. but I just don't know. It could be extremely icy. We could maybe not have any ice, but just bare ground. And if we have bare ground, we could still do the lantern lit.
Yeah.
It's just we wouldn't have the snow there. But so that Patrick, we discuss that almost every day in the office with staff. It's just the ice is the worst thing. If it's icy, we just can't hold a lantern lit or snowshoeing. If it's icy, it's too dangerous. But let's see what happens. How much snow melts, how much ice is left behind, how much hopefully new snow we get on top of this.
Well, I just also wanted to ask you that because if people are by chance out to the state park on Thursday or Friday and they see you kind of dancing around or something, you're doing
Yeah, I know. I'm watching the weather really close and just praying that that cold air is just far enough south that it's going to make it snow and not rain. And that's my only hope I have. And but we'll have to wait and see what happens.
You do have a comment thanking you for the presentation from a participant that they very much enjoyed it.
Well, I'm happy that they enjoyed it. There is so much more I want to talk about the Great Lakes, but I know time is a factor, and maybe in the future we can talk a little bit more about it.
I'd encourage people also to consider joining Alan in nicer weather when he does his history walks. I've had the opportunity to do a number of those with him at the state park. If you've not taken advantage of those, Alan, you offer those a number of times, different interpretive walks in the state park starting in the spring
Right.
through early fall, correct?
That's correct. Yes, I do. History walks, I think they let people know the unique, not only features of this park, but how this park was shaped by people before us.
So you can have that to enjoy. And again, Alan's in the park throughout all the seasons. We're very fortunate to have him based out of the Ludington State Park. And he also, as I mentioned earlier, coordinates the entertainment program for the Friends Group. The Friends Group funds it, but Alan goes through the process of booking all the acts and arranging.
They're all booked.
They're all booked.
I just now need to share them with the board, get their okay, and then Steve will take them. Steve will make a poster, and then we'll advertise it to everybody. Just got them all booked the other day.
Okay, well, that's good. So thank you, Alan, for the presentation this evening. Have a great rest of your evening, and I look forward to knowing that your snow dance was successful on Saturday when we're out there for the snowshoe hike.
We'll see everybody hopefully this Saturday for the last of the snowshoeing and the lantern lit. So thank you.
And if you would like any information again on the Friends Group, please visit our website and don't hesitate to drop us an email. And hopefully, if you're not a member, you'll consider joining the organization. Thank you all for participating and have a great evening.
Thank you.